Colby Bradford. This is my submission for embedded operating systems, homework 2. Here's my potentiometer hooked up, and then my 2 LEDs. And these wires all come over here to the breadboard. I'm using ADC1, and then I've got 3.3 volts in ground hooked up right there. And then over here we have, this is where the LEDs are connected, and these pins are doing PWM to control their brightness of the LEDs. So you can see over here right now the potentiometer is putting out next to nothing, and this LED here on the right is really bright. I don't know why it unfocused. And this one on the left is not even on. So let me see if I can do it up this way to where I can turn this to the right, refocus my camera, and as I turn it to the right, I can't really show it on the recording, but the potentiometer values are starting to climb. You can see the right LED's dimming, the left one's starting to brighten up, and as I keep turning and turning and turning, it's the right one's dimming more and more, and it's kind of hard to show in the video because it's really blurry right here for some reason, but the left one has gotten like way bright. And then if I go back the other way, turn to the left and not have my screwdriver come off the thing, and I'm falling. You can see that one on the right hidden behind the yellow wire is starting to light up some more, and again it's kind of hard to see in the video, but the left one is dimming down. We are now passing the 40 mark, so it's gonna start getting really dim here. It's a lot dimmer than when it started, and the other one is a lot brighter. And then we've just crossed into the single digits. There's the threshold for that guy. And this one is really, you can see he's on there. He's kind of hard to show. There we go. So that's the demo. Now here's the reading the values, and can try and turn it a little bit just to. So I'm turning the potentiometer to the right now, and we can see it's going to start increasing. So I just wanted to show that real quick. Now into the code. Up here I'm going to make 2 duty cycles because I wanted to have 1 duty cycle for one LED and 1 for the other. Up here is you have to include STDIO and string. That way you can send the strings later on through, I forget the specific function down here, it's sprintf. But anyway, I opted to just use one timer. I'm using timer 2 and channel 1 and 2 of it to control the different LEDs. I didn't really want to use 2 different timers. And then right here is my float, which is going to have my voltage and the buffer. And down here, we're going to start the analog to digital and the PWM on both of the pins. And on the putty, we just have like a starter note here. So I can come over here and hit the reset button on my board real quick, and there's the start message. And so anyway, what we have going on in the code here is pretty much the exact same as what we did in class, except because I want these guys on a scale of 100, I figured that was the easiest way versus trying to find out, do it like half of 3 or 3300 and whatnot. We're going to multiply ADC result here by 100, that way it's on like a percentile scale. On the sprintf, we're doing 6.2F and then just a tab. And this we're putting the what's it called? Oh yeah, the voltage here. I don't know why that keeps slipping my mind. We're sending the voltage through sprintf over to the UART, and there we are sending it. And here's the first duty cycle. We're just going to use the normal voltage, and then for the second duty cycle we are going to do 100 minus the voltage. That way we get it so that they move in opposite directions, since this one will be the negative of this one. So as this one increases, this one will be decreasing, if that would get out of my way. And as this one increases, where this one will be decreasing. And then we just put a delay here just to keep it nice and separate. And that's my, well, I guess I could do the IOC too. So over here I have mine set to 9,000 bits. My putty gets really weird if I go past that. Over here's my pinout. We can see PB9's where the timer channel 2 is going, and then PA5's where timer channel 1 is. My ADC's on pin 1. For the connectivity, let's go to analog ADC. We've got our sampling flag at the end of all conversions and the continuous conversion. For timers, we have timer 2, and we can see here the important thing is both of our things are on PWM generation. And lastly, for connectivity, come down here to UART and move this guy up. Oh, I started with UART. Okay, that's everything. Thank you.